Ladies and gentlemen, please welcome to the Subsurface stage, Sanjeev Mohan, Vice President and Analyst at Gartner.
Hello, everyone. Welcome to the final session of the July 2021 Subsurface Conference. You made it to the very end, and we have saved the best for the last. I am so delighted to be here today to talk to you in front of these four esteemed innovators in our open source community. This is an open source panel, and it gives me great pleasure today to talk to you with people who have created some of the most influential products in the market. We take these products for granted, but it took a few of people on this panel to create things like Parque. So Parque was a project that started in a number of different companies from these people. They collaborated and they came up with the open source format that we now use it for our analytics on mostly cloud object stores. Pandas is another one that many of you have used, which also came from the panel, and also the new ones that you've been hearing about in the last 2 days, like Project Nessie or Apache Arrow. So the purpose of this panel right now is because we want to take a peek into the minds. Like, who are these crazy people? What goes off in their minds that they feel compelled to come up with a new innovation? So that's the first question that we want to understand, that what compelled them to come up with a new approach. The second thing that we would love our panel to tell us about is what were the missteps along the way? What were some of the lessons that they learned as they went about in creating the new open source project? The last thing that we want to find out from them is what's next. What are they most excited about? What will complete this journey? So before I introduce the panel, it is very exciting to see that a journey that we started in the open source many decades ago seems to be coming together. We finally seem to be in a place where in open data architecture, we now have a set of open source projects that complement each other, and they help us build out an end-to-end solution. So with that, I would love to introduce to you the panel today. We have two Ryans on our panel. The first one is Ryan Blue. Ryan Blue is the co-creator of Apache Iceberg. He is calling us today from Boise, Idaho, where he has moved to start his new venture called Tabular. We have Ryan Murray. He is calling us from Munich. He is a co-creator of Project Nessie, and he is an open source engineer at Dremio. Julian Ledem is calling us from Berkeley, California. He is a creator of Open Lineage and co-founder of a company called DataKin. He is also Apache Arrow PMC member. And finally, we have Wes McKinney. He is calling us from Nashville, Tennessee, and he is also an Apache Arrow PMC chair, creator of Pandas, and he is co-creator, co-founder, CEO of Ursa Computing. With that, I will hand over to Ryan Blue. And Ryan, please tell us what made you create Iceberg.
Mostly complaining users. I just needed to make those support questions go away.
That is amazing. So what kind of questions were they asking you?
Well, pretty regularly. We had a system for making changes atomic, where any insert or change to a table would actually overwrite data silently. So you needed to know that was happening. So like actually making atomic commits work as expected, making schema evolution work as expected, hiding partitioning from users so they didn't have to deal with that all the time. It was it was just a bunch of different user issues that made us zero in on the table format as the next thing that needed to be evolved.
That is great. And Brian Murray?
Yeah, so when we started thinking about Project Nessie, we were really thinking about the progression of the data lake platform over the past 10 or 15 years. We've seen slowly a lot of people on this call have been building up abstractions, whether that's abstractions to help with compute or abstractions for things like tables and data files and that kind of stuff. And we started thinking, what's the next abstraction? What's the thing that makes the most sense? And what we saw was it was a meta store, a catalog that sits on top of the table formats and can help interact with some of the other things. So for us, it was trying to identify what's next in these layers of abstraction that is making the data lake easier and easier to use.
So, Brian, we already had Apache Hive.
Yeah, we did have Apache Hive.
So
I think it's the same way that Ryan Blue felt that Apache Hive wasn't quite well suited for the table format. I think the single point of failure, the huge number of API calls to that metastore, even the thrift endpoint made it really hard to scale. It made it really hard to use effectively, especially in a cloud native way. So looking at something that was going to be cloud native and would work with modern table formats, and we could start thinking about extending to all the other wonderful things that my co-panelists are building is what we were really thinking of.
That is great. So it seems like, things that we've taken for granted in the relational world, some of the best practices from the age-old data warehouses like data modeling, transactional support. So we are bringing those into the new era of big data, if you may. Would you say that's where we're heading?
Yeah, I think so. I think the transactions are a huge part, and I think that's the reason Ryan. I don't want to let Ryan introduce transaction as much as Ryan did. So I think it's important to hear from everyone. But I think it's transactions are a really important aspect for the data loss stuff that Ryan was talking about, and for conceptually how do people deal with the data lake. I think the transactions are really key element to that.
Great. So Julian, and what was your rationale for various open source projects that you've been involved in?
Yeah, so if we talk about Parque, I think Parque came first from Iceberg, and Nessie we come add the layer that we're missing on top of it. Parque was very much looking at, there was Hadoop that would scale very much, but not very high latency queries. And on the other end, at least at Twitter, we had Vertica, so kind of more traditional data warehouses that were lower latency queries, but didn't scale as much as Hadoop. And so it's we were always in between the two options. And I think some of it was making Hadoop more like a warehouse, right? Starting from the bottom up, starting with the columnar representation and make it that more performant, following the tracks of all those columnar databases. And so really that was the beginning. And this it just makes sense as you go up the layers. The next missing layer was the table format, the transaction layer, how we abstract that better, because Parque is just a file format, right? So it just makes things more performant for a query engine, but it doesn't deal with anything like how do you update a table, how you do all those things. So we needed that layer on top, and it was great to start seeing this happening in the community.
So, and what about open lineage? What was the reason for that?
So I think one of the drivers also for this open, storage architecture is because there are a lot of people don't use just one tool, right? They use things like Spark, they use things like Pandas, they use warehouses where they're, like the SQL and Hadoop type, things like Dremio or Presto, but also other proprietary warehouses. And so there's lots of fragmentation, but they still want to be able to use all those tools and do machine learning on the same data. So having this common storage layer makes a lot of sense to standardize this so that you can query it and transform data from various sources. And the same thing applies to visibility in the lineage graph of data, right? So if you care about understanding dependencies between those things, right? It's like you might have a dashboard at the end, but you care about how all this data came to be and when it's coming from your ETL or your raw source of truth data. And so Open Lineage is the same thing, right? Like now we have this somewhat fragmented, very heterogeneous environment where people might use different tools for different jobs, but they still need to understand how the whole ecosystem works together. So Open Lineage is really about standardization. And so really following in the tracks of how do we standardize columnar storage on disk or in memory with Arrow. And Open Lineage is about standardizing lineage across all those things. So really tracking each transformation as it happens. What was the version of the code? What was the schema of the input? What was the version? And the nice thing about those transactional storage layers is you can keep track of what version you depended on and what version you produced. And so really capturing this across the entire graph of transformation. So I think that really we're getting to the point where we do need to get visibility across everything.
That is great. So that's yet another piece of the puzzle that we're solving. So which takes us to Wes. So Wes, can you please enlighten us with some of the rationale for your involvement with the open source space?
Yeah, so along with Julien, have been involved in Apache Arrow since the very beginning. Around 6 years ago, we recognized that we had developed, the community had developed Parque as an open standard for data storage and data warehousing for data lakes and for the Hadoop ecosystem. But we were increasingly seeing this rise of application and programming language heterogeneity, where you need to, applications are increasingly bottlenecked on moving large amounts of data between programming languages, between application processes, and going through a more expensive intermediary, like Parque, to move data between different steps of the application pipeline was very expensive. And so the idea of Arrow is to have a language independent, compute engine independent representation of tabular data, which can be used for very fast transport between computing processes and used for in-memory processing. And we found that it's portable across computing hardware. You can use it on GPUs and CPUs. For me, the motivation was that I wanted to provide an efficient means for the big data ecosystem and for data warehouses to be able to export data at very high speed into the data science ecosystem, because I had been working to build pandas in the Python data science ecosystem, and you had all of these big data systems that were struggling to make data available to data scientists. And so Python was becoming really popular, really important in 2014, 2015. And so the idea of Arrow is let's give all these applications a single point of efficient import and export. So since then, Arrow has been adopted by many different databases, data warehouse systems, big data systems, Spark and BigQuery and Snowflake and all these systems as a means of interchange. And that's really radically simplified the process of getting data into the data science world or transferring data between these different computing environments.
That is great. So thank you, Wes. I am very keen to have you talk more about where all Arrow is being used in what other places, but we'll hold on to that so we can make sure we cover all our questions here. So I'll go back to Ryan Blue. Ryan, what were some missteps, lessons learned along this journey?
I don't know that I would characterize things as missteps as much as just a process of getting better. If we look at what Iceberg is doing specifically, because I think that's one of the ones I'm most familiar with, there's the period of innovation where it's about getting something working at all, and then the next phase is getting it to work well. And that's sort of where my previous comment about taking care of all these user issues and user complaints comes in, because we had something that worked and did a good job in certain areas like Hive tables. But we realized through that whole process of innovation that we needed to have these other features. We needed to bring back SQL semantics and things like that. So I would say our missteps were really just the evolution of going and saying, let's do something that works, even if it's imperfect, which was really necessary. And then moving on to where we are today, where we've had a chance to rethink and rebuild a lot of those components.
So if you were to do it again, would you do it any different?
Iceberg or other things? Yes, I would probably do some of the sequencing and features a bit earlier, or probably do the Iceberg v2 stuff a lot earlier than we are, the row level deltas. But then I think that might just be that we're seeing GDPR type use cases now, and so the benefit of hindsight.
Yep. Yeah. Very true. Yeah. And Ryan Murray, same question for you.
Yeah, I think I really agree with Ryan Blue on this one. I think to call anything a misstep or a mistake, I think you need the benefit of hindsight to be able to do that. The past 15 years has been all about, we had this new paradigm, and now we have to figure out what to do with this new paradigm. And of course, we're going to make some missteps. We're going to make some mistakes. We're going to go down some blind alleys. But it's like scientific discovery. There's no such thing as a failed experiment. Every failed experiment teaches you something new. And I think that's what I've seen is we could have done things differently, but we didn't know then, and we had to make mistakes to be able to get to where we're at now.
That is true. Yeah. Yeah, because I know, Julian, you have quite a bit to say on this, because when you were working on Parque, for instance, you had to be very sure that whatever you are going to do is going to stay forever in the open source community, right? I mean, so what was some of your thinking process?
Yeah, that the thing about creating a file format is like any mistake or bug happening along the way stays forever, because once the data has been written in that specific format, so any design mistakes or underspecify element of the spec that leads to heterogeneity of implementation, we have to deal forever. So it's something, and we've been very careful, and Ryan and Wes remember some of those steps, but of course some of those slipped, and then you have to deal, you have to maintain the code that will deal with the three cases that can happen somewhere, right? You'd like to have a very much cleaner implementation, but because the initial spec was underspecified in some area, then you have to deal with the three different ways it's been implemented because of a lack of specificity. So it's something, that's something you have to deal with when you store data in a format, and then you need to be able to read it. And it stays with you forever. And I think that's informed other things along the way. So it made us more careful with time on how we specify the metadata and certain things. And I think I'm also taking some of that in the way OpenLineage is being designed, is really taking some of that into consideration, making sure we're really enabled versioning of different aspects of the spec independently. We track, identify the origin of the metadata. I think in case of OpenLineage, it's a little more forgiving because this kind of data is more transient, right? Like how the data was transformed a long time ago may be less relevant. But it's something, we definitely learn from in terms of what's the best way to specify metadata, how to make sure there's no room for interpretation, and be really clear in those aspects.
That is great. Thank you. Wes, how about yourself?
Yeah, I would say, echo the other sentiments around, having the benefit of hindsight, but it's hard to predict what people what will be most important to people in the future. And so in the Arrow project, for example, we, early in the project, we were faced with a choice. Do we invest in hardening, cross-language testing, interoperability, and data access tools versus building computing frameworks which are Arrow native? Like at that time, like we had Dremio, which was Arrow native from the very start, but we didn't have Arrow native computing frameworks for Python and C++ and for other programming languages. And so now that we've built kind of this hardened standard for interoperability, we've made it stable, we've got lots of systems to adopt it. Now we've got tons of people clamoring for computing frameworks which are Arrow native so that they can process all of this new Arrow data that's flying around in their systems. And so, it's easy for people to criticize and say, hey, you should have been working on more computing frameworks that are Arrow native 3 or 4 years ago. But at that time, we were really concerned with getting people to use Arrow in the first place. And so, I think that there's always like that, kind of people kind of showing up at the project later and questioning like your choice of priorities throughout the lifetime of the project. But I would say, all in all of these projects, like we've applied like our engineering best practices and our learnings from other projects that we've done in the past, and that, by replicating and trying to avoid the mistakes of the past, has generally led us down like, very reasonable paths. I think also like something to be said for working in the Apache Software Foundation, working in the open. So like our ideas are being continuously vetted by the community and like presented for comment. And so that kind of, sanitizing the work with the light of day, I think really helps with helping avoid, doing something which is like obviously a bad idea, because people generally will chime in and say, hey, I don't know about that. Maybe we shouldn't solve the problem that way.
So, Wes, which products today are using Apache Arrow?
So it's used very actively in the Python world as a means of fast data access and interoperability with pandas. So Arrow is used to connect pandas with Apache Spark, with Parque files, ORC files. We've built a framework for fast data transport called Flight, which is on top of gRPC. There's an extension for Flight called Flight SQL, which is intended to be a replacement for ODBC and JDBC. So we're really keen to see the overall kind of speed of data access, holistically improved across the board. Arrow has also been really successful as a preferred bulk export format for data warehouses. So it's been adopted in Google BigQuery and Snowflake. I'm blanking on the other name I was thinking of, but so data warehouse vendors have adopted it and see it as like the fast on-ramp for data into tools like Pandas or in R or other systems that already speak Arrow. So that's been exciting to see.
That's great. Yeah, great progress. I'm sure you had no idea at that time that this is how far Arrow will go.
Well, it was certainly my objective. So I'm happy that we were successful in achieving our goals, and I think that the interoperability with the JVM, the Java ecosystem, was one of the big problems that was facing the ecosystem in 2014 as Python was becoming more popular, because a lot of the Hadoop ecosystem was Java based, and so there wasn't nearly like the concern of like how do we get data out of the JVM and into native code, C code or Python code. So to have that interoperability problem for large tabular data effectively solved, between the JVM and the outside world, is a real boon for the community and has made application development a lot simpler for other open source developers.
That's great. That's fantastic. So I want to go back in the remaining 5 minutes we have. So Ryan Blue, what excites you? What's next on your plate?
I'm really excited about I think the space that Nessie occupies and sort of evolving metastores, and also I think part of that is making the ecosystem just easier and easier to use. That continuing that evolution. For a long time, you needed, an army of data engineers as well as platform people. And I'm happy to see things sort of coalescing around these technologies, things getting easier to use, and companies that are, making it possible to have a small organization that can take advantage of this stuff rather than, needing that 20-person data platform team.
That's great. So you talk about Nessie. So Ryan Murray, what about you? So he's stolen some of your thunder. You can steal.
No, I think it's I agree completely with Ryan. I think the what we've seen is, I think it's starting to happen now, and what I really hope to see in the near future is for people to stop talking about Parque and Arrow and Iceberg and Nessie and stuff. Is if we can, I think a lot of data engineers I've interacted with are thinking about how big is my Parque file and which directory does it belong in, so it gets taken, so that partitions get taken advantage of, and how do I make sure that it has the right schema and all this kind of stuff. And I think we're so ready to just stop talking about that. So that engineers can just start writing SQL and applications on top of these things, and move beyond all these great things that have been created. Not move beyond, because they're still under the hood, of course. But it's let's raise the bar of abstraction so that people can start doing interesting things on top of what we built.
That's great. I have noticed that data engineering is probably one space that is the most in flux in entire data and analytics. And why I say this is because traditionally we've done data engineering in a silo. The data engineer has written code, but now we are seeing there's a more DevOps pieces happening. There's more automation happening, which it seems like it's the last bit of data and analytics which needed to catch up with all the best practices of SDLC. Would you say that's the case?
Yeah, I think there's some pretty good memes you can find on Twitter and LinkedIn and stuff of data engineer CVs, data engineer job specs, which are can you do everything that has ever been invented effectively? And I'd love to see the data engineer job spec get a little bit smaller.
Yeah, that's so funny. Right. So, and Julian, how about yourself? What's next exciting for you?
Yeah, I think along those lines, when we talk about operations, I think the data ecosystem is quite behind compared to service world, right? Like in the service world, notion of SLAs, a lot of things are well defined. Where in the data world, we're just starting to adopt all of this, right? So the notion of data observability, tying together data quality metrics and how the transformation is happening, how the code has been deployed, how this is changing over time, right? Because you have this complex graph of dependencies of transformation, and you may be changing your product or changing how you collect data about your product, changing your source of data, or you may have like many source of data, your ETL system when you ingest, and a lot of transformation. And all of that is constantly changing. You have a bunch of teams who consume and produce data. And you need a lot of observability of how everything's changing, so that if your dashboard is wrong or the machine learning model is 2% less accurate and that impacts your bottom line, you can really quickly understand where this is coming from. So really that's why, I've been pushing on the open lineage and really taking a page out of the Arrow playbook on how we start an open source project and reaching out in the community, building this together. And by the way, or today went out the announcement that it's part of the LFAI and Data Foundation, which is part of the, the equivalent of the CNCF, but for data. And really making this a reality, having a standard, how we express those transformation for every job that runs, what were the input, what were the output, what was the version of everything, keeping track of that and building this lineage graph really at the run level. Every transaction that's happening, understanding the lineage of it in this vast ecosystem. So, that's kind of the layer on top of everything you talked about with Parque, Arrow, Iceberg, Nessie, and like the transformation on top and with open lineage. So I'm really excited about bringing this visibility across the ecosystem and having the same kind of conversation that have been happening with Arrow over the past few years.
Yeah, so which takes us to Wes. Wes, what's exciting for you next?
Yeah, I mean, I'm really excited to take Arrow into its next stage of development, which is the building and deploying Arrow native computing engines into all of the different places where data is accessed and data is processed. So I think Arrow has been really successful as a tool of accelerating data access, but it hasn't yet made its way as a system that can, or a toolbox that can accelerate everyday analytical computing around like a lot of the projects that you use in your day-to-day work. And so I think our goal for Arrow is for it to be largely invisible to you, and so something that the developers of other projects that you use can incorporate into their systems and make them faster and more efficient, more scalable. And you as a end user wouldn't have to think as much about it. So that's what I'm excited about, and what I see like the next several years of my open source development career, where I see it taking me.
That is fantastic. Amazing story. I'm so happy to see the journey of where you guys started and what's coming next. Stay tuned, everyone. Thank you for joining this panel. Really enjoyed having everyone on. Till next time, thank you. Bye-bye.
Thank you.
Thanks.
Thanks.